Hello student, welcome you all in the lecture number 5 of the lesson number 2 Introduction to Analytical Chemistry. In this lecture, we will focus the topic limiting reagent and problems on it. In this slide, we begin with the example of limiting reagent. लिमिटिंग रिएजंट्स स्टडी करण्यासाठी विद्यार्थी मित्रमैत्रिणींनो आपण आज किचनमध्ये जाऊया. हो, अरे नाश्ता करण्यासाठीच. माझ्याकडे 6 पावाच्या स्लाइसेस आहेत व 2 चीजच्या स्लाइसेस आहेत. 2 पावांच्या स्लाइसेसमध्ये 1 स्लाइस चीजची असे टाकून मी ब्रेड चीज सँडविचेस तयार करणार आहे. तसेच परत 2 पावांच्या मध्ये 1 स्लाइस चीजची घातली व दुसरे ब्रेड चीज सँडविच बनवले. असे 2 चीज सँडविचेस बनवले. त्यासाठी मला लागलेले आहे 4 ब्रेडच्या स्लाइसेस आणि 2 चीजच्या स्लाइसेस. 6 पैकी ब्रेडच्या 4 स्लाइसेस लागल्यामुळे 2 ब्रेडच्या स्लाइसेस उरल्या. येथे चीज इज लिमिटिंग रिएजंट तर bread is excess reagent. In the next slide, we will see definition of limiting reagent. The reagents which gets consumed and limits the amount of product form is called limiting reagent. In this first point, when chemists carry out a reaction, the reactants are not usually present in the exact stoichiometric amount, that is, in the proportion indicated by the balance equation. Number 2, this is because the goal of reaction is to produce the maximum quantity of useful compound. We call that as a product from starting material. We call that as a reactant. Frequently, a large excess of reactant is supplied to ensure that more expensive reactant is completely converted into the desired product. Third point, the reactant which is present in the lesser amount get consumed after some time. No further reaction takes place whether the other reactant amount is left in the reaction mixture. So, limiting reagent is the reactant that get consumed completely and limits the reaction. अशा प्रकारे लिमिटिंग रिएजंट म्हणजे असा रिएक्टंट की जो पूर्णपणे रिएक्शन मध्ये वापरला जातो, रिएक्शन कंप्लीट करतो, याला लिमिटिंग रिएजंट असं म्हणतात. इन द नेक्स्ट स्लाइड, कन्सिडर द फॉर्मेशन ऑफ nitrogen dioxide from nitric oxide and oxygen. In this, step 1. First of all, write the correct equation of the chemical reaction. So, twice NO, that is nitric oxide, plus O2 gives nitrogen dioxide. Twice NO plus O2 gives twice NO2. Step number 2. Write initial moles of the reactant and product. Here, initial moles of the reactant nitric oxide is 8 and oxygen is 7. Initially, no product is formed. Therefore, number of moles of product is X. In the step 3, write stoichiometric coefficient for both the reactant as well as product. Here, stoichiometric coefficient of nitric oxide is 2 and oxygen is 1, whereas nitrogen dioxide is 2. Step 4. Write mole S2 stoichiometric coefficient, that is the ratio of mole S2 stoichiometric coefficient. So it is for nitric oxide it is 8 upon 2, for oxygen it is 7 upon 1 and for nitrogen dioxide it is X upon 2. Step 5. Out of nitric oxide and oxygen which have low value of above ratio is the limiting reagent. Here nitric oxide has ratio 4, oxygen have ratio 7. So out of these two, nitric oxide have low value of this ratio. So NO that is the nitric oxide, is limiting reagent, whereas the value of O2 is high, therefore oxygen is excess reagent. Step 6. To calculate number of moles of product of NO2. Here, to calculate number of moles of product NO2, that is nitrogen dioxide, we have to take two ratios. Ratio of nitric oxide and ratio of nitrogen dioxide. Why here we have to take the ratio of nitric oxide? Because nitric oxide, it is the limiting reagent. So we have to take these two ratios. Okay. Now 8 upon 2 is equal to x upon 2. 8 upon 2, it is the ratio of NO, that is the nitric oxide. X upon 2, it is the ratio of nitrogen dioxide. 2x is equal to 16. X is equal to 8 moles of NO2. So किती moles of NO2 तयार झालेले आहेत? 8 moles of NO2 तयार झालेले आहेत. Step 7. How many moles of O2 is used? किती moles O2 हा वापरला गेलेला आहे? इनिशियली O2 चे मोल्स दिलेले आहेत. किती आहेत ते? 7. परंतु O2 हा एक्सेस रिएजंट आहे. म्हणून 7 चे 7 मोल्स वापरले का? नाही. तर 7 पेक्षा कमी मोल्स वापरले गेलेले आहेत. ओके? मग किती मोल्स वापरले गेलेले आहेत ते कसं काढायचं आहे? यासाठी आपल्याला दोन रेशो असे घ्यायचे आहेत. बघा, एक ऑक्सिजनचा रेशो घ्यायचा आहे आणि एक NOचा रेशो घ्यायचा आहे. ओके, सो NOचा रेशो आहे 8 upon 2 which is equal to x upon 1. हा ऑक्सिजनचा रेशो आहे. x upon 1 हा ऑक्सिजनचा रेशो आहे. यावरून आपल्याला किती मोल्स ऑफ ऑक्सिजन हे वापरले गेलेले आहे ते कळणार आहे. बघा, 2x is equal to 8, so x is equal to 4. 7 मोल्स पैकी 4 मोल्स ऑफ ऑक्सिजन हे वापरले गेलेले आहे. मग किती मोल्स ऑक्सिजनचे उरलेले आहेत? 7 minus 4 is equal to 3 moles of O2 is left. Okay, students, followed this problem. So, what are the tricks to solve the problem on limiting reagent? पुस्तकाप्रमाणे सॉल्व करायला गेल्यानंतर थोडी डिफिकल्ट मेथड आहे, म्हणून मी तुम्हाला काही ट्रिक्स सांगणार आहे, मी काही स्टेप्स देणार आहे, त्या आता अगोदर आपण बघूया. सो सॉल्व द प्रॉब्लेम्स ऑन लिमिटिंग रिएजंट इन द नेक्स्ट स्लाइड. स्टेप नंबर 1. राईट बॅलन्स इक्वेशन ऑफ द केमिकल रिॲक्शन. बॅलन्स इक्वेशन लिहायचं आहे केमिकल रिॲक्शनचं स्टेप 1 मध्ये. स्टेप 2. राईट नंबर ऑफ मोल्स ऑफ रिॲक्टंट. नंबर ऑफ मोल्स ऑफ रिॲक्टंट कसं लिहिणार? कुठल्या फॉर्म्युल्याच्या साहाय्याने लिहिणार? N is equal to W upon M. या फॉर्म्युल्याच्या साहाय्याने रिॲक्टंटचे मोल्स काढून घ्यायचे. स्टेप 3. राईट स्टॉइकियोमेट्रिक कोएफिशियंट ऑफ रिॲक्टंट अँड प्रॉडक्ट. स्टेप 4. इट इज कॉल्ड मोल स्टॉइकियोमेट्रिक रेशो. यालाच मोल मोल ॲनालिसिस असंही म्हणू शकतो आपण. So next, step 5. The ratio out of these two is smaller is called limiting reagent, and the ratio which is larger is called excess reagent. Step 6. Limiting reagent and product ratio are compared to get number of moles of product. Step 6. By using formula N is equal to W upon M, which is equal to W is equal to Nm, weight of the compound can be calculated. So these are some steps. In the next slide, we will see actual example. So problem number 1, read the problem carefully. Again and again I have told you. See the problem. 56 grams of nitrogen reacts with 30 grams of hydrogen to form NH3, that is ammonia. Calculate number of moles of NH3 formed and weight of NH3 formed. Solution. Step 1. Write balanced chemical equation. Come on, N2 plus thrice H2 gives twice NH3. Step 2. Calculate number of moles of each reactant by using the formula N is equal to W upon M. So 56 upon 28, which is equal to 2 of nitrogen, 30 upon 2 equal to 15, it is of hydrogen. And initially the number of moles of ammonia is X. Step 3. Write stoichiometric coefficient. Stoichiometric coefficient of nitrogen is 1, hydrogen is 3, ammonia is 2. Step 4. Divide number of moles by stoichiometric coefficient. For nitrogen, 2 by 1. For hydrogen, 15 by 3. For ammonia, X upon 2. Out of these 3, which is having the smaller ratio? 2 is the ratio of nitrogen, 5 is the ratio of hydrogen. So, out of these two, nitrogen having less ratio, hydrogen having greater ratio. So, nitrogen is the limiting reagent and hydrogen is the excess reagent. Step 5. As nitrogen is limiting reagent, so number of moles of NH3 is. Now take these two ratios, ratio of nitrogen and ratio of ammonia. Why we have to take here ratio of nitrogen? Because the nitrogen is limiting reagent. So 2 upon 1 is equal to N upon 2. So N is equal to 4. So number of moles of ammonia is 4. What is the weight of ammonia? Weight of ammonia is equal to, by using the formula N is equal to W upon M. So W is equal to Nm. So number of moles of ammonia is 4. Weight of the ammonia is 17, which is equal to 68 gram. So answer here it is, number of moles of ammonia is 4 and weight of ammonia in grams is 68 grams. Problem number 2. In the next slide, we will see 6 grams of hydrogen reacts with 32 grams of oxygen to yield water, which is limiting reagent. Find the mass of water produced and amount of excess reagent left. इथे प्रॉब्लेम मध्ये सांगितलेलं आहे की वॉटर इज द लिमिटिंग रिएजंट. ओके, परंतु आता परत आपण एकदा सॉल्व करूया अकॉर्डिंग टू अवर स्टेप्स. बघा, स्टेप नंबर 1. First write balanced chemical reaction. So balanced chemical reaction is twice H2 plus O2 gives twice H2O. Hydrogen and oxygen both are in the gaseous state whereas water is in the liquid state. Number 2. Find out the number of moles. N is equal to W upon M. So number of moles of hydrogen is equal to 6 upon 2, which is equal to 3. And for oxygen, 32 upon 32, which is equal to 1. Initially, the number of moles of water is N. Number 3. Write down the stoichiometric coefficient. Stoichiometric coefficient of hydrogen is 2, oxygen is 1, and water is 2. Fourth step. Divide number of moles by stoichiometric coefficient. 3 upon 2 for hydrogen, 1 upon 1 for oxygen, and N upon 2 for water. Mole stoichiometric ratio for hydrogen is 1.5, oxygen is 1, and water is N upon 2. Out of these two, hydrogen and oxygen having less value of the mole S2 stoichiometric ratio. So, oxygen is limiting reagent and hydrogen is excess reagent. Let us calculate number of moles of product, that is the number of moles of water. So which two ratios we have to take? Ratio of oxygen and ratio of water. Why here we have to take ratio of oxygen and water? Because oxygen is the limiting reagent. So let us take these two ratios. Ratio of oxygen is 1 upon 1. Ratio of water is N upon 2. So 1 upon 1 is equal to N upon 2. N is equal to 2. Number of moles of water is 2. What is the mass of water then? For the mass of water, use the formula N is equal to W upon M. So, W is equal to Nm, which is equal to number of moles of water is 2. Molar mass of the water is 18. 18 into 2 is equal to 36 gram. Amount of hydrogen left can be calculated as it is excess reagent. In the next slide, we will continue the problem. Amount of hydrogen left in the reaction. Amount of hydrogen left in the reaction as it is excess reagent. For this, take hydrogen and oxygen's mole S2 stoichiometric ratio. What is the stoichiometric ratio of hydrogen? It is X upon 2. Number of moles of hydrogen upon 2. And for oxygen, number of moles of oxygen upon 1. What you have to calculate? You have to calculate amount of hydrogen left. So leave it as it is. N of H2 upon 2, which is equal to N of O2 is 1 upon 1. Next step, NH2 is equal to 2 moles. किती amount hydrogen वापरले गेले? 2 moles of hydrogen is used. Now convert this N, number of moles of hydrogen, into gram. कसं करणार? N is equal to W upon M. W is equal to N into M. तर number of moles of hydrogen किती आहे? 2. त्याचं molar mass किती आहे हायड्रोजनचं? 2. So 4 grams of hydrogen is used during the reaction. 6 grams of hydrogen पैकी 4 grams of hydrogen हे यूज झालेलं आहे रिॲक्शन मध्ये. किती ग्रॅम्स ऑफ हायड्रोजन उरलेला आहे? तर 6 minus 4 is equal to 2 grams of hydrogen is left. आता आन्सर काय काय आलं बघा. ऑक्सिजन इज लिमिटिंग रिएजंट, हायड्रोजन इज एक्सेस रिएजंट, mass of the water is 36 grams, amount of hydrogen left is 2 grams. We can verify this answer by putting appropriate values in the equation of the chemical reaction. बघा काय आहे chemical reaction चे equation? Twice H2 plus O2 gives twice H2O. हायड्रोजनचे किती ग्रॅम मास घेतलेले होते? 6 grams. ओके. ऑक्सिजनचं किती ग्रॅम मास घेतलेलं होतं रिॲक्शन साठी? 32 ग्रॅम. ओके. किती ग्रॅम प्रॉडक्ट तयार झालेला आहे? 36 ग्रॅम. ओके. 6 ग्रॅम्स हायड्रोजन पैकी किती ग्रॅम्स हायड्रोजन वापरलेला आहे? 4. So 4 plus 32 is equal to 36. And how much grams of the hydrogen left? 2 grams of the hydrogen is left. Here we have completed problems on limiting reagent. Thank you.